We have is 4.6 properties of logs. Today we're going to talk about expanding logs, and tomorrow we're going to turn right back around and go backwards, which should be really easy once you get today's lesson. Okay? 3 rules. This goes for today and tomorrow. You've got properties for products. If I start off and I'm multiplying things together, for example, here you've got log base b of m times n.
So it's pretty much exactly like exponents.
Yeah, it's exactly what it is. So when I'm multiplying, I'm really adding. So if you think about your exponents, I'm pulling them back apart. Okay? A good observation. That's b. These are all letters. Okay? Quotient property says if you're dividing, you're subtracting. Okay? This is the one that's a little bit different. The power property says when you've got something raised to a power, and I've mentioned this in class before now, that exponent can come right out in front of the log. And you can rewrite it as n times log base b of m. Okay? The challenging part here is I'm going to throw a whole bunch of things together and mix it all up and ask you to apply these whenever it's necessary. Sometimes you're not going to be able to apply any of them, and you're done. It's just not reducible, not expandable. Sometimes you're only going to be able to apply certain ones. And you're going to have to know exactly when it applies and when it doesn't apply. Okay, the more you do this, the more experience you get, the easier this becomes. But this is your tool. If you know this, then today and tomorrow's lesson should be pretty much straightforward.
Are those B's or 6?
Those are all B's, all letters. No numbers on this at all except 4.6.
The end of power property is the
It's just n times log base b of m. Like you're taking the log of m.
It's just
Yeah.
Is it? What about on quotient property on the last?
No. They're all just they're nothing. You don't raise the base to any power ever. The base of the log is it's just there. You're not really going to ever do anything to that. Okay, I'm going to put an example on the board for you. Everybody got this down?
No. Wait, but.
Okay. So let's do an example. Log base 4 of z squared times the cube root of x. Now, I'm going to need you to remember a few things. How do we convert square roots and cube roots to exponential stuff? How do we write that with an exponent?
1 over
X to the what? 1/3. Good. Remember, roots, whether that's a square root or cube root, turn into fractions. That root is on the bottom, so it's 1 over whatever the root is. So here's how we're going to work this out. We're going to basically start it off. We're going to say log base 4. What rule did I use to do it this way?
the first one. Don't know what that is.
It's the one about multiplying, right?
Yeah.
Because I multiplied the z squared times the cube root of x, what we multiplied now, it just gets separated into a sum. Logs stay the same, bases stay the same. Nothing really changes except I'm going to be pulling them apart, and so we're going to add these two things. I'm going to take the log of each one. Okay, so does that make sense? It's z squared. Sorry.
And then it's cubed.
Right. So what are we going to use now? What rule do I have to apply next?
I don't know.
It's the power rule. Because now we don't have anything multiplied. I don't have anything being divided. I don't have any fractions. But I do have things with exponents. So what do we say about the exponent? What's the rule it says? Bring that exponent. We go back. Look.
So the price.
If you go back here, what's happening to the exponent? We have to bring this exponent.
We can't see what you're doing. The power property. Oh, no, we
Oh,
can't.
bro.
The exponent comes out front. That's where you get this from. So if we go back here, you get this. We have the first part, 2 comes out front, and you've got 2 log base 4 of z, and you're done with that property. There's nothing else to do. I can't apply the product rule. I can't apply the quotient rule. I can't apply the power rule anymore. I've already done those things.
Hang on 1 second.
I can use it as much as needed. The cube root of x becomes x to the 1/3. Whenever, you might write this down. Whenever you have a radical, you're going to have to convert that to its exponent form. Because you need to know that exponent so that you can bring it out front. And you can see here, we took that 1/3, we brought it out front, and whatever was the base, it stays behind, and that's as far as you can go.
Wait, whenever you have a radical, you what?
Whenever you have a radical, convert it to its exponent form. And that's how you would do this particular problem. Little confusing at first, but I guarantee you, most of you, if you do a couple of these today and you get comfortable with the rules, you'll see the answer in your head before you even write it down. Okay? I could do that,
Is
and I
it
could.
to the x at the end?
No, it's of x.
It's just x.
It's just x.
You're not like
Listen, guys. No, that's the answer. The goal is to just expand it. All right, so let's talk about, we brought the 5 out. Okay, I like to use brackets sometimes, parentheses, it doesn't matter. The subtraction says you subtract the log of the top minus the log of the denominator.
Wait, don't you have to pull that 6 out?
I'm not done yet, but yes. Shh. I need to make sure that we're all on the same page now. Remember, if you're not sure why we did something, go back to your rules. Those rules need to just kind of be rote. It needs to be kind of, I get the rules. I don't need to be looking back at the rules, because if you don't know the rules, then you definitely won't know what to do. What would be next?
I don't know.
Remove the 6.
You're not allowed to have any exponents in your answer. Okay, let's bring out that 6.
So it'll only be on that log, not on the other log?
Correct. Look, you can only have that applied to one of the logs. It's not both. And to finish it out, we could even take this a step further and say
30 log x, or log 7x. Bro.
30 log 7, log base 7 of x minus 5
7 y.
of y. And that way I don't need any parentheses. Okay? That is the final answer after it's all expanded.
Yeah, why did you put the 5 right there?
See, I know what you said you can have.
Yeah, why'd you put a 5 on
Okay.
the other side?
Because I had to distribute the 5 here and here.
Oh!
Okay?
Right, is this all?
Yeah, no. Okay?
Do you have to do that though?
Yes.
You said if you want to.
All right, let me pull up, let's see, some others. Okay. 13. It's really not hard once you look at it. So it's log base 3 of the cube root of x, y, and z. My suggestion to you earlier was whenever you get a logarithm or a radical, change it to its exponential form. So we have to rewrite it like this. Log base 3 of x, y, z to the 1/3 power. Once we got it to the 1/3 power, we can bring that 1/3 out front. And we can have it log base 3. Now I can go ahead from here, and I'm going to go ahead and expand this part out because I know it's multiplication. That means I'm just going to go ahead and add all these parts together. So log base 3 of x plus log base 3 of y plus log base 3 of z. And then I can distribute the 1/3 into all of those values to finish it out. So 1/3 log base 3 of x plus 1/3 log base 3 of y plus 1/3 log base 3 of z.
That's the answer.
And that's the final answer.
How do you do
35. Right there. 35 is a little bit weird because it's all numbers, kind of like number 7. But don't feel, if you feel the urge of just, you could technically calculate this one by punching your calculator. That's not what that's not my goal. Today my goal is simply to get you to expand using the rules. So take the 3 out front and then distribute the 3 after you do the subtraction. So we finished this one out.
But then you're condensing.
No?
Yeah, you are. It gets smaller.
I don't think so.
Yeah, it would.
If you can factor it out, that's making it smaller.
Well, you can factor it out once you put it in.
But don't.
I don't get the LN part.
That's just the natural log. That's the same as LOG.
You don't change it?
No.
It's just
It's remember it's the base is E. It just has a special, you don't do anything to it.
Different at all?
No. Nothing changes. The natural log, instead of writing LOG, you're just going to write LN. It has a base of E. 2.72. Which, remember on the previous ones, did you ever do anything with the base? No, it stayed the same. It never changed. So the fact that the bases changed won't affect your work, period. Okay? And so you have this as your final result. Let's look at number 32. A lot of you wanted to talk about quotients. Okay? If we finish this one out, good. It would be 12 log base 5 of x minus
You're not doing 32.
33. 3
So you're not doing 32?
log base 5 of y. No. So that would be your final answer for that one. Just by distributing. The fact is we have a fraction. That's key phrase. That's my identifier for when do I use a quotient rule. When I've got things multiplied, I'm going to use the exponential rule. Or the product rule, I guess. Okay? Any questions?
No.
Okay? 27. Look on the screen. You see 27 at the top. 27 starts off as z times the cube root of x, y. So I see that it's product first. Break it into its sum. I change the cube root to the 1/3 power. Okay? Right here. And then, because it's x times y, and I've got a power, in one step, I applied the power rule by bringing the 1/3 out and distributing it to each of the x log and the y log, and I added those together because it was a product. So you end up with log base 2z plus 1/3 log base 2 of x plus 1/3 log base 2 of y.
You can do that in your head.
You get it?
You guys are going to be able to do that when you get used to this. Okay? It's a matter of experience. It's a matter of getting used to the rules. And you're like, oh, I've done this like 5 times. It always happens this way. That's where you begin to really understand what you're looking at.
So what's
Okay? Your homework was to do the 2 through 40 even.
2 through what even?
2 through 40 even. You'll find a lot of this stuff, and it won't take you, I would expect if you 10 to 15 minutes, and that's giving you lots of time, you should be able to finish the majority of this in about that time frame. So
What? We don't have 15 minutes. We have like 40.